All right, so in this video, we are continuing talking about linear functions. So the first thing, once we know what a linear function is, we can actually graph it. So we're going to graph a line. So this is what's known as a coordinate grid. Okay, it has an x-axis, which is horizontal, right? And it has a y-axis, which is vertical. And where they meet up, right here, is your point 0, 0, aka your origin. Okay, so what we're going to make sure is that all of our equations are going to be in the slope-intercept form. So this y is equal to mx plus b. Okay, and basically what you're going to do is you're going to plot the y-intercept, aka your b, and then you're going to use your slope to find the next point. Okay, and then using a ruler or straight edge, you're going to connect a line through the points and draw arrows at both ends. Okay, 2 points make a line, 3 points we will find make an even better line. All right, so let's get started on 2 practice problems. Okay, so our first one is y is equal to -3/2 x plus 5. Feel free to pause the video at any time, try it on your own if you already know how to graph, or follow along. Okay, so for number 1, I'm going to state that my slope is -3/2, and it doesn't matter where the negative is attached, either in the numerator or denominator, and your b value is 5. So this is your y-intercept, and it is a point, which is 0, 5. So I'm going to come over to my origin, and I'm going to go up 5, so 1, 2, 3, 4, 5, and I'm going to make a point. And then I'm going to use my slope to draw one more point. So my slope is, my change in y is 3, so I'm going to go down 3, 1, 2, 3, and then over to 1, 2. I'll be at the point 2, 2. And then I can do that one more time. I can go down 3, 1, 2, 3, 1, 2, and then I have my 3 points. So like I said, 2 points make a line, 3 points make a better line. What we're going to do is we are going to connect these points together. I'm going to extend through and draw my line a little bit better. I do not have the ability to show you a ruler. I will make it a little thicker so we can kind of see it right there. All right, so notice that I extend past the first point that I drew and past my second point. This will help us later on when we have to graph system equations and inequalities. Okay, now if you're going to plot more than one graph on a grid, you need to label that graph. And one way that you can label it is just by saying the number 1, because that 1 represents that one that we put right next to the y is equal to line. The other way we can do it is we can literally just write the equation again towards the bottom, out of the way, so I know when I look at that line which equation goes with it. All right, so for the second one, again, I'm going to state my slope, which is 2, and that is the same thing as saying 2 over 1. And then my b value this time is -3, so aka 0, -3. So I'm going to go down 3, 1, 2, 3. And I'm going to use my slope, so I'm going to go up 2, 1, 2 over 1. Make a second point. I'm going to go up 2, 1, 2 over 1. And I can keep going using my pattern until I get to my end. Now, everyone usually goes to the right, but you can also go to the left. I can also graph down. So instead of up 2, what I could do is I could remember that 2 negatives make a positive, so I could go down to 1, 2, and then run in the other direction. Okay? Either way is perfectly fine. As long as, again, you have 2 points, they make a line, 3 points make a better line, and extend through your points using your lovely ruler. Again, make it thicker. There you go. And draw arrows at both ends. We're going to label this. So I've labeled this number 2, so that means I'm going to call this equation number 2. That's one way to label it. Or again, I can label it the actual y is equal to 2x minus 3. So once we actually create equations, create graphs, what we can do is we can write equations from a graph. So there's not a box in your toolkit for this information, but we do have an empty box. You can put that information in there, or at the bottom of the page, or just on a separate sheet of paper. Okay, so when you're writing an equation from the graph, there are two things you want to find, right? You want to find your slope, your m, and your y-intercept, your b. Okay, and again, we're going to plug it in, mx plus b. If you don't know what your b is, right, we can use our slope and we can use another point. So I can say, or if y-intercept is difficult to find, plug in another point and find b. Find b. Okay, so again, notice how my graph is labeled 1, 2, 3, and 4. So when I write my equations, I'll make sure that I label it 1, 2, 3, and 4. Okay, so let's start with graph number 1. All right, so graph number 1, I see that the y-intercept actually looks like 3 of the graphs have my y-intercept at the point 0, 3. So that's my b value, so I don't have to worry about finding it. And then my slope, I got to look to see where it's going to go through kind of another corner of this grid. So I can see this is a point on my graph, this is a point on my graph, this is a point on my graph. So again, how do I go from left to right? It looks like if I make a little triangle, looks like I go over 1 and up 2. So it looks like my slope, I don't know why I wrote the number 2 down. We should not have done that yet. Sorry. So m is equal to 2 over 1, or aka just 2. So that means my equation for right now will be y is equal to 2x plus 3. So that's one way we can write an equation from a graph. All right, let's try number 2. All right, so again, it looks like my b value is 3. So I'm going to show you how we are going to find the b value if we were not given with this one. So let's pretend I don't know. I see that it's these 2 points. So I can easily see that my slope is 1, and then I'm going over 2. So I'm going to say my slope is 1/2. And then I can either use the point -4, 1, right? Or I can use the point -2, 2. It doesn't really matter. So what I'm going to do is I'm going to plug in. So I'm going to use the point -2, 2. So I'm going to say that my y value is 2, my slope is 1/2, my x was -2, plus my b value. So we know that our b is 3, but let's pretend we didn't know that. So 2 is equal to 1/2 times -2, which gives you -1. And notice that we did, in fact, get our b value as 3. So this equation of this line right here is y is equal to 1/2 x plus 3. Okay, so no matter how you find how to find your b, it's either given to you or you have to plug in and solve for it algebraically. That's how we're going to write an equation from a graph. Okay, so why not pause the video and try equation number 3 and 4 right now. All right, so I'm going to go to another slide so that way we can see it a little bit clearer. So for 3, all right, I see that my b value is 0, -3, or aka just -3. And it looks like my slope is going up 1, 2, and then over 1. So 2 over 1. So for equation number 3, we should have gotten 2x minus 3. And then for equation number 4, again, it looks like it's going through, again, the b value of 0, 3. But this time your slope looks like you're going down 2 and then over 1. So this will be y is equal to negative 2x plus 3. So those are your answers. Okay. Anytime we are looking at our graphs and we don't know what we're doing, I want you to realize that there is a relationship between everything. There's a relationship between your graph, right, your equation, and your table, right? We've been kind of focusing on going back and forth between a graph and an equation, or an equation to a graph. But again, we can always go from a table to an equation and a table to a graph, and vice versa. So we'll get extra practice with tables to graphs and tables to equations in another on another day. All right. So what else can we do with graphing lines? So we have two particular lines and that we want to talk about, and they're known as parallel and perpendicular lines. Okay. And maybe you've heard this before. Parallel lines. It's the saddest love story in math because these two lines, they'll just never meet. Okay. So here's our kind of definition. So parallel lines are the lines in the same plane that never intersect. They always have the same distance apart. Okay. And how we represent parallel lines, which will help us later on when we talk about a little bit of geometry and angles and stuff like that, are these arrows on your lines. These help us represent parallel lines. So again, they never intersect. Oops. So we want to make sure we highlight that. They never intersect. Now, perpendicular lines are very specific types of lines. So they are lines that meet, but they are going to meet at a right angle, okay, aka 90 degrees. So we can see that with that little, almost looks like a chair in the corner. Okay, so yeah, parallel lines, here's a little symbol for two parallel lines, and then perpendicular. You don't have to worry too much about the symbols at this moment. We will cover that later on. Okay, so what makes parallel lines never intersect is that they have the same slope. So in your toolkit, you should be copying this down right here. Parallel lines. If the lines have the same slope, right, they are parallel. So M1, excuse me, is equal to M2. And then in our perpendicular box, we can write if the slopes are negative reciprocals. Okay, which basically means if I multiply them together, I'll always get a negative 1. Okay. So examples of parallel lines. This is also a symbol that we use for parallel lines to vertical lines, I should say. So if my M1 is equal to 4, then my M2 also has to equal 4. Okay. So that would be one example. All right. Or my M1 is equal to negative 1/3. That means my M2 also has to equal negative 1/3. For perpendicular, so what does it mean to be a negative reciprocal? So basically what this means is that you're going to start with your first slope, and let's just say our first slope is 5. A negative reciprocal, so you're going to take the opposite, so the opposite of a positive number is a negative number, and then a reciprocal just means I'm going to flip these numbers around. So I flip the 5 and I make it 1/5. So in reality, if you multiply these numbers together, so 5 times negative 1/5, the 5, right, is going to become negative 5/5, which ultimately gives you negative 1. So that would be an example of reciprocal slopes, right? You could also do this. So M1 is equal to, let's say, negative 2/3. So notice it's already negative. So that means a perpendicular line would have to have a positive, and then we flip our fraction over. So 3 over 2. Okay, so again, we can test that out by multiplying these together. So this will leave us with a negative 6 over a positive 6, which ultimately, again, is that negative 1. Okay. So to recap, parallel lines are never going to meet, right? Same slope. Perpendicular lines looks like they make, they cross at a 90-degree angle. So your x-axis and your y-axis are examples of perpendicular lines. Now, any line that is not perpendicular, but they intersect, we just call intersecting lines. These are clearly not meeting up at a 90-degree angle. Okay, so one common mistake people have is everyone assumes that once they meet up, once two lines cross, it has to be perpendicular. Not the case. Okay, so I want you to look at these problems, and I want you to ask yourself which ones are parallel, which ones are perpendicular, or which ones are neither. So again, take a moment, pause the video, figure out if all of them are parallel, maybe all of them are perpendicular, maybe some of them are, some of them aren't. So figure out which ones are which. All right, so I noticed that this line has a 3 and this line has a 3. So they are the same number, which means 3 is equal to 3. So these are parallel. Okay. What do I notice about the second example? So the second example, I have a 1, and for my first slope. And then for my second slope, I have a negative 1. So clearly they are not parallel because they're not the same. But if I multiply them together, I do get negative 1. So these must be perpendicular lines. So perpendicular, I'm going to abbreviate it to that. And again, the reciprocal of 1 is also just plain old 1. And then finally, my last example, I see m was equal to 2, m2 is equal to negative 2. So I see that they're opposite. So they're not the same because they're not the same number. They're opposite, so maybe they are perpendicular. But if I multiply those two numbers together, I'm going to get negative 4, not negative 1. So this would be an example of neither. All right. So one thing we can actually do with parallel and perpendicular lines is we can write equations of the line. So I'm going to say this. Given y is equal to 1/2 x plus 7, write write an equation of a line that is parallel to the given line and goes through the point, and let's do the point as 10, 3. Okay, so what would this look like? All right, so what we're going to do is we're going to write an equation of a line. So y is equal to mx plus b. So because I said the word parallel, I know that I'm going to use the point 10, 3, and that my slope should be exactly the same. So 1/2. Okay, so this is my x, this is my y. What I don't know is my b value. So I'm going to plug in my y, plug in my m, plug in my x, plus the letter b. So 3 is equal to 1/2 times 10, so that'd be 5. Subtract 5 to both sides, I get negative 2 is equal to b. All I have to do is write an equation. Y is equal to 1/2 x minus b. And that would be my answer. All right. So let's try one on your own. That way you have a second example. So let me get rid of that. We don't need that. All right, so given y is equal to negative 3x plus 1, write an equation of a line that is parallel to the given line and goes through the point. And let's say the point is 1, negative 3. All right. So go ahead, pause that video right now and see what you get. All right. So if you pause the video, let's see what we got. So we got parallel line. So I know that my slope is negative 3. This is my x. This is my new y. So again, y is equal to mx plus b. So my y, negative 3, slope, also negative 3. X is 1 plus b. So negative 3 is equal to negative 3 plus b. I add 3 to both sides. I get 0 is equal to b. That's exciting. So my brand new equation will be y is equal to negative 3x plus 0. You don't actually need the 0, so you can just leave it as negative 3x. And that's all you have to do. So the same steps are going to work if we have to find a perpendicular line. So let's try one example together for perpendicular. And get rid of that. So given, and let's say y is equal to 5x minus 1. Write an equation of a line that is perpendicular to given line and goes through the point. And let's say our point is negative 15, comma 7. Okay. So remember, perpendicular means that your slope is the opposite reciprocal. So I gave you a positive number, so it's going to be negative. And then we're going to flip the 5 to make it 1/5. And here's my x, here's my y. So again, mx plus b. My y value is 7. My slope is 1/5. My x is negative 15 plus b. This is going to leave me with 15 over 5 plus b, which I can simplify down to just 3. I will subtract 3 to both sides, leaving me with 4 as my b value. So I plug in what I know. I plug in the 1/5 in for m, and then plus 4. So this line is now perpendicular to that line, but goes through the given point. All right. So try one on your own. And again, I'll get rid of that. So this time, given y is equal to, and I'm going to give you negative 4 over 3, x minus 6. write an equation of a line that is perpendicular to a given line and goes through, let's see, this time it's going to go through 20, comma 14, right? So go ahead, pause the video, try this one now, and see what you get. All right, so if we are coming back, oops, so sorry. If we're coming back from the pause video, so the first thing that you should have done is found your slope. So I'm going to flip that to make it 3/4. It was negative, so I'm going to make it positive. This was my x, this is my y. So again, y is equal to mx plus b. 14 is equal to 3/4 times 20 plus b. Now, here, my 20 and my 4 can simplify, leaving you with 5. So this will actually be 15 plus b. I'll subtract 15 to both sides. I get -1 is equal to b. So my equation is 3/4 x minus 1. Okay, so we dealt with parallel lines, we dealt with perpendicular lines. The other two lines that are kind of similar, and they are two types of perpendicular lines, are known as vertical and horizontal. So let's chat about those. So vertical lines, they just cross the x-axis, which means they will have an x-intercept only. The equation will always be x is equal to some sort of number. Okay? Horizontal lines, they cross the y-axis. So this will be a y-intercept only. And it will be y is equal to some sort of number. If we recall, there are 4 types of slope, and one of the types of slope is your zero slope. So that means horizontal has 0 slope. Okay? So if you actually write it as y is equal to 0x plus a b value, notice that this guy right here is going to go away. So you'll really just be left with y is equal to b. So your number is your y-intercept. But for vertical, this is actually undefined slope, right? So undefined slope, which means I can't write it in the y is equal to mx plus b. So I have to know it's just a number. Okay. So what do I mean by this? So I have a graph here for some help. So what happens if I drew a line, and let's make it thicker so we can actually see it on my graph. So here's a line. Notice it's vertical. So again, if I drew arrows at the end to indicate it goes on forever and ever. So notice that it crosses just your x-axis. It's undefined slope because you're just having a change in y and not a change in x, right? So this would just be written as, say, x is equal to the number 2. And that's it, okay? I can make a copy, and I can put it anywhere else on this lovely graph. So if I put it over here, right, notice again, it's crossing your x-axis. At what number is it crossing? It looks like it's crossing at -5. So my horizontal line is just x is equal to -5. So things I like to remember is if it only crosses one axis, that's what your equation is equal to, and where it crosses is the number. For horizontal, right, horizontal, it's going to look something like this. So again, it's going to cross. I'm going to move this in a second because it's not crossing it exactly where I want it to be. And I'm also going to change my color to make it a different color. Okay. So again, notice that this is crossing, oops. So notice this is crossing my, here we go, y-axis. Arrow, arrow. So it's crossing only one axis. It's a horizontal line. So again, 0 slope. So this would just be an example of y is equal to 3. Again, I could take a copy of this and I could put it maybe right here. And this would be an example of y is equal to 1. So notice that two horizontal lines are parallel to each other, right? Notice that two vertical lines are parallel to each other. Horizontal and vertical lines, these two types of lines are perpendicular. Perpendicular. So this is a clear example of a perpendicular lines. Okay. Now, the last two things that we're going to address is the x-intercept and the y-intercept. Now, we've already kind of addressed the y-intercept. We keep knowing that it crosses the y-axis. So the x-intercept is what we're going to kind of focus on. So again, things I want you to remember about the x-intercept, right? So it crosses the x-axis. It will always be x, comma, 0. Your y-intercept, again, just in general, it only crosses the y-axis, which means it's going to be 0, comma, a y value. For our sake, for lines, we know we're going to be dealing with the b value. So it's the b value for lines. Okay, so how do we actually find this? All right, so I'm going to say find the x and y intercepts of the equation y is equal to, and let's go with 1/2 x plus 12. Okay. All right. So it's important to make sure that we do label our x and our y-intercept. So I'm going to put my x-intercept first. So what I'm going to do is I'm going to plug in a 0 in for y and solve for x. So I'll subtract 12 to both sides. I'll get negative 12 is equal to 1/2 times x. I will multiply by the number 2 because division is the same as multiplying by the reciprocal. And 2 times negative 12 gives me negative 24. So that means my x-intercept is negative 24, comma 0. For my y-intercept, let's make a little y-intercept. All you have to do is remember that your y value is your b. So all you have to do is say 0, comma 12. If you didn't remember it was this, then we are going to just say y is equal to 1/2 times 0 plus 12. 0 times 1/2 is 0. And notice that we get y is equal to 12. So again, we don't have to do a whole lot of work to find our y-intercept. It's the x-intercept that we have to do a little bit of work. So go ahead, try one more. So let's go y is equal to negative 4x minus, let's go 30, right? Minus 30. So go ahead, pause that video, try to find your x and y intercepts right now. All right, so if we're coming back unpaused, so x-intercepts, y-intercept. So the y-intercept, it would be the easier one to find first. So 0, comma, negative 30. It could be whatever number I thought of, and that's the number I thought of. And again, how we found that, in case you forgot, we can plug in a 0 in for x. So we get 0 minus 30, which is going to give us that negative 30, or aka this is our b. For the x-intercept, this one's a little bit trickier. So 0 is equal to negative 4x minus 30. I'll add 30 to both sides. So 30 is equal to negative 4x. And then I will divide by negative 4. Now, 4 does not go evenly into 30, which is fine. Leave it as a fraction. So we will get the value as 15 over 2. So that means my x-intercept will be negative 15 over 2, comma 0. So that's your x-intercept, and then we have our y-intercept. Again, if you want to leave it as a fraction, that is perfectly fine. If you wanted to write it as a decimal, right, so you wrote it, I ran out of room over here, so I'll just write it over here. So if you wanted to write it as negative 7.5, comma 0, that's perfectly fine. All right. If you have any questions or concerns about any of the topics that we covered in this video, please let me know or Miss Barron know.